Kubernetes 1.25 feature CSI ephemeral inline volumes secret store CSI driver. So if I go to the browser around 1 month back, Kubernetes 1.25 CSI Inline Volumes have graduated to GA, which means since last 2 years it's already there as a beta feature, but in 1.25 it's become a stable, which is general available. So let's try to understand. So before that, let's try to understand what is CSI and what is inline volumes, what is ephemeral inline volumes, and what is secret store CSI driver. So CSI driver, so if you look at the CKA or CKS point of view, so we have used CSI driver point of view. Let's try to understand. There is a one cluster and master node and worker node, right? And as we know, master node have a kube API server and as well as a kubelet, and also every worker node will have a kubelet, right? And there is a one pod, it's a regular pod, say just assume like an Nginx pod, and let's say there is a cloud providers, right? And these cloud providers offering AWS, Azure, GCP. For example, AWS is offering two types of storages. There are other as well. One is the EBS block storage and file storage point of view EFS, and Azure point of view Azure disk, Azure file. Google cloud point of view persistent disk and file storage. These are the similar types of storage. If you want this pod to store the data in the cloud, this CSI driver will be in the picture. So for that, what you will do, first you will be installing a CSI driver. Yes, if my pod wanted to use AWS, just install a CSI driver of AWS and then make use of it. Same thing for Azure and Google Cloud. So first you will install a CSI driver, then after that you will create a storage class which tells what type of a storage you wanted to use, whether this or this or this or this, if it is a Azure. And from the storage class you will define a provisioner who will take care of the provisioning. Say I want the EFS of say 20 GB in my pod. Yes, something like that it will take care. Then after that, and during the CSI it will install the controller plugin and a node plugin as well, and we need not to know much details about the controller and node plugin, right, unless you develop some plugins. So after that, persistent volumes will be created and persistent volume claims will be attached to the pod. So these are the very high level step which CSI driver is provided. So overall, by looking at this particular picture, what we understood is, in order to use this particular pod, to use any of the cloud storage, CSI will use, and CSI will provide a driver, storage class, provisioner, and accordingly it will create a persistent volume. Persistent volume means permanent volume here. Persistent volume claim. Out of this volume, how much is your claim? 20 GB, 5 GB, 2 GB, something like that. And this is called a dynamic provisioning. If pod uses 1 GB, it will be deducted from here. If it is pod uses 100 GB, it will be deducted from here. If you kill the pod, no problem, your data will be there here. This is all called a dynamic provisioning. So still, CSI, what is CSI? And CSI will use as a gRPC communication, right? And which is much better than a REST API communication internally, right? Now for the CSI driver, CSI is nothing but container storage interface. Yes, in the previous slide we all talking about the storage. So CSI is all talks about the storage, right? That's a one primary. CSI basically talks about the its a specifications of a storage for whom? Container orchestration services. Container orchestration service, one of the biggest is Kubernetes, and internally the CSI driver uses a gRPC communication, so which is invented by the Google, starts with a G, and Google's remote procedure calls, and which is much better than a REST API, and it has many features, right? And CSI driver provider, one is dynamic provisioning, just now I have shown in the previous, right? It will increase gradually dynamically, and you can use the block storage or file system storage in your pods in the container. So we are talking about the Kubernetes and we are talking about the storage. right? So and this CSI driver will provide storage. You can attach, detach, right, as we have seen in the previous slide. And also the CSI driver provides local storage, volume, raw volume. You can do the snapshot, you can clone, etc. All the facilities you can do if you install the CSI driver. And last but not the least about the CSI driver, CSI driver also provides secrets from the cloud, keys from the cloud, certificates from the cloud as a persistent, permanent, and as well as ephemeral, which is temporary, right? So that's the whole purpose of the CSI driver. Now dynamic provisioning. In the CKA, what we have seen is dynamic provisioning point of view, there will be a storage class and there is a provisioner, as we have seen in the previous slide, right? Provision is, I wanted to use a dynamic provisioning of a AWS EBS, elastic block storage volume, and here the type is GP2, etc., and volume binding mode immediately, etc. So this is a storage class I define. This is my target, and where I will create a persistent volume claim where I will map the storage class. This is a class name I given as a standard, and read write, etc., and I want a 3 GB, and I will attach this particular storage persistent volume claim first as a volume at pod level, right, and as a persistent volume claim which is defined in the previous in the YAML, and container level VolumeMount, and you will attach here. So all the storage is attached here. This is a dynamic provisioning an example. Storage class, persistent volume claim, and ultimately pod. Of course the user is end user is a pod. Now volume and VolumeMount. So here persistent volume, right? Now VolumeMount and HostPath. So let's say there is a 2 pod definition. This is a 1 pod definition where volumes are at the pod level. One is a host path. Host path, I have created 2 different volumes, and volume mounts are in the container level inside. One pod can have a multiple container. So what this host path will does is, this will map to the local directory of the host where the pod data want to store, whether you wanted to create or read only or whatever. And empty directory, if you specify a pod with an empty directory as a volume here, right, and container level you mount the same. Container level you will be mounting any type. What's the difference is empty directory, whenever you create empty directory, it will be shareable across the multiple containers in the pod, whereas the host path, basically the data will persist in the host path. But whereas empty directory, whenever you delete the pod, automatically this empty directory specific data will be deleted. That's the difference, right? And of course the volumes at the pod level, volume mounts are in the container level. Now secret usage. Say if a pod wanted to use a secret, which is a CKA syllabus, CKS EKS, how we will use. Let's say in a Kubernetes there are secrets. Let's say secret 1 and secret 2 I have created, right? kubectl secret create generic, something like that. And there is a pod, and this pod has 2 containers, container 1 and container 2. I want to use the secret 1 in this container, secret 2 in this container as a environment variable. So it's possible by using secret key ref. How? This is the pod definition. I wanted to expose as an environment variable in the pod, in this particular container, where you are referring the secret as an environment variable, right? And there is another way where you can mount this particular secrets as a volume at pod level, but container level volume mounts. How? Something like this. So volume, this volume is I wanted to mount a secret which is called a test secret, and mounting you can choose any of the path, so that it will be, this particular secret will be mounted as a volume. That's how typically in the CKA what we learn. Now this is a today's topic, CSI Driver Secret Store. So if you look at the today's topic is this is right, ephemeral inline volume secret store CSI. So now this is a Kubernetes cluster. So we will come to the what is this, and right, this is a master node and this is a worker node, right? And of course master node will have a kube API server and kubelet, and worker node will have a kubelet as well. And you have an Nginx pod, right? And of course the communication will happen from kube API server to kubelet, and the kubelet will talk to pod. And there is a cloud environment where here we are talking about the secrets, right? Here in the cloud in AWS we can store the secrets in secret manager, Azure Key Vault. Google Cloud point of view will store in a secret manager. HashiCorp also will store it as a secrets, right? If this pod wanted to use the secret as a volume, use the secret as a volume, Kubernetes offers a secret, right? In the previous slide, right? The previous slide, Kubernetes offer the secrets, you can mount it here, but in order to do that you need to create a secrets here. But here basically here you wanted to use a cloud secrets as a temporary, so the CSI driver is used. In order to do that, first you have to install a driver. Say I wanted to use the AWS, install AWS driver. If you wanted to use Azure driver, you install where in the Kubernetes. And if you wanted to use a Google Cloud, you have to install. So when you install a driver, then CSI driver will be installed in your machine. Then second is you have to install a provider of whom, AWS or Azure, GCP. This provider will install as driver specific permissions etc. in the Kubernetes, because this Kubernetes has to talk to this guy, right? The cloud. The third one is this pod specific, you have to create a provider, means this pod has to connect to ultimately secret manager. So you need to create a CRD by following the CSI driver specs. Then CSI volume will be created and CSI VolumeMount will be created, and that CSI VolumeMount will be attached to the pod. So ultimately this secret will be mounted to the pod as a temporary, which is ephemeral. When you delete the pod, automatically this VolumeMount will go away. Super, right? So it's a dynamically this cloud secrets will be attached to the pod. That's what the CSI driver will take care. I hope this gives the picture. So let's try to understand more about this. And of course this communication is on the gRPC based. The first one is generic ephemeral volumes. So if you look at the today's topic is ephemeral inline volumes. So these ephemeral volumes are there since 2 years. So CSI ephemeral volumes and generic ephemeral volumes, these are the two types. So the first one is generic ephemeral volumes. So what exactly it is say there is a pod name is this, and pod has a volume which is ephemeral is the type. Ephemeral is nothing but a temporary, but whereas here you are defining a volume as a volume claim template with the proper specifications. I want ephemeral, which is temporary volume, 1 GB of this particular storage class depending on the driver you install, and I want in a read write mode etc., and mount it to my pod. That's what the, but what is the difference is this is an ephemeral. So by using this, what's the benefit is basically, you say your worker node is a smaller capacity and you wanted to attach a network storage as a volume which is a higher size, bigger size. Say your worker node is a 5 GB and you wanted to attach a storage of 20 GB, then your worker node memory and all memory, CPU and all the capacity, it will be exceed, right? So that's why this generic ephemeral volumes will be used, and this is same like a empty directory. So what is empty directory is in the CKA we learned empty directory is whenever you delete the pod automatically the empty directory will be deleted, and empty directory volume will be shared among the containers. One volume can be shared to the multiple, and most important is when pod deleted, this volume will be deleted. That's what the same generic ephemeral volume. But what is extra? This future ephemeral inline volume, generic ephemeral volume, can be handled by any driver. Means you have a Kubernetes native driver, AWS, GCP, there are many other CSI drivers, right? And that any of the driver. And by the way, the drivers list is here. There is a official page. There are so many drivers, right? It's a list, it's given, right? So any of the driver can handle. And other one is the benefit of the comparison with the empty directory and generic ephemeral is this particular ephemeral storage can be local or network attached. Even though it's a temporary, but it's will be local or any network attached. And another benefit is, and of course whenever pod dies, this volume will be deleted. And another thing is volumes can be fixed size, so you have to specify here before attaching this temporary volume, which is ephemeral volume 1 GB, 2 GB or whatever, right? And another advantage of the generic ephemeral is you can do the snapshot, clone and reserve. Even though it's a temporary, but you can clone, snapshot, etc, etc. That's a benefit. And the second one is CSI ephemeral inline volume, which is actually talking about the today's topic. So what exactly it is? So first one is this particular ephemeral inline volume is provided by the CSI driver. CSI driver is container storage interface driver, right? And this is a driver name, and this driver is provides a storage as ephemeral and in a inline fashion. And this CSI driver is basically the major key role here. If CSI driver supports this CSI ephemeral inline volume, then you can use it to the pod. So this is a driver with the volume lifecycle mode. This is either ephemeral or persistent. That's a property of this particular CSI driver. And pod point of view, here if you look at here, this is a pod has a volume as a CSI driver specific volume. So this particular driver, which is same as the driver you install in the Kubernetes cluster, right? So what exactly it's providing is this driver is talking about the secrets only. Secret store CSI K8s.io means this driver will do the duty of secrets, put it as a volume, and then VolumeMount. And volume attributes nothing but this particular driver specific, what are the attributes you will pass. Accordingly this driver will do the job for you. This is the inline volume, so this inline, and this is the ephemeral. So as soon as this pod will be deleted, automatically this secret will be deleted. That's what the today's topic. Then next, same thing, CSI ephemeral inline volume. There is a one example. This is a pod, simple pod, right? And volume, some name is given. Volume is a CSI driver provided volume, right? So this driver is by intel.com, right? pmem-csi.intel.com. So if you go to the drivers list, right, say intel, right, Intel, so you found this Intel volume, right? And this driver provide a persistent and as well as ephemeral both, and container storage interface for pmem from Intel, right? So and here in the previous slide we have seen, right, this driver ephemeral or persistent. So when you are defining a driver, you have to tell that it's a persistent or, right? And this particular driver specification point of view, I want a 2 GB and file type is XFS and mount it here. And there is an example is given, right? So right, so here if CSI driver is supported, then only it works, this ephemeral. If that means some of the drivers are only persistent, some of the drivers persistent and ephemeral, right? If you look at here, Intel Flash Black Storage supports only persistent, which is, this is a different company, right? And most of the companies providing as a persistent only, but HP Enterprise is providing a persistent and ephemeral of what? Container storage interface only, right? Google Cloud is offer. So there are many drivers here, you can go through that, right? And it has a properties etc is defined. Now go back to the slide, and if this CSI driver ephemeral inline volume is something like a temporary scratch disk by cloud provider. This intel.com is also one of the cloud provider, right? So because he's providing a storage right here, temporary scratch disk, nothing but whenever you have a scratch disk, you will scratch it once and just throw. Once you see the number and then you will throw, it will expire. Same thing, whatever you achieve by using this Intel driver, it will be deleted once the pod is deleted, right? So yeah, its volume is exists until the pod life cycle, that's what I mean, and reattached after the pod restart. So whenever you restart the pod or recreate, then automatically it will be reattached from this guy Intel. And it's a specific sample YAML file also I have. This is Intel driver pod, which is simple, right? And let's go back to the slide. And what is the benefit of using this volume as a CSI driver is you can populate a dynamic secrets from the cloud. That's what it means. So if Intel provides, because here Intel, right? So let's try to intel.com, right? So this Intel is only supporting a storage, right? Not a secrets, right? Means like if this driver supports whatever the functionality you can achieve. For now this Intel is supporting only the storage specific only, that is a XFS, right? And by the way, it's a specific, it's available here in their GitHub documentation. This example is taken from here. In fact, if you go here and here, it's available already there. That's what I have taken, right? Now let's go back to the slide, right? And depend on the driver capabilities. Yeah, that's the most important. If you are using any of the driver, the capabilities must support, right? And go to the driver documentation, right? So right here, supported access modes. So right here, some driver provides. So we'll see the one example here, right? Now CSI driver image populator, this is another example. So this is a one pod, and pod is Nginx, we know it's a Alpine, and which has a volume. And here the volume I am using image.csi.k8s.io, which is, this is the driver, right? It's a simple driver which is provided by image.csi.k8s.io. The beauty of this driver is you can attach another Docker image as a volume and you can mount it to pod, right? A Docker image as a mount in another pod. That's what the image populator. So you cannot achieve with any other driver. So this driver only will support that, right? Image.csi. So let's see if this is available here. Image.csi, it's not there because it's a default still under the dev mode, right? So that's what it means, container image as a volume here to the another pod, which is currently still in the development environment. I think somewhere I found in the example, yeah, I think this is the one, CSI driver image populator. There is a GitHub page where you can play with that. You can do if you have a 1.25 version, right? And CSI driver, yes, it's a CSI, purely CSI driver based, and depend on the driver capability, yes, that we have seen, right? Now the demo. So for the demo point of view, I will take one Kubernetes cluster and I will run an Nginx pod, and that pod is going to use the AWS secret manager secret in the pod as a volume mount. For that I am going to perform all these steps. So, and I am going to use the CSI driver as a AWS one. You can use Azure or Google Cloud, any other. And by the way, for this particular point of view, Kubernetes Kubernetes store CSI driver. So there are multiple drivers are there, and it's a documentation and installation is available in this particular directory. So how you have to install AWS, Azure, GCP, Vault providers, etc. And if you wanted to use the secrets as an environment variable secrets, as you can sync the secrets, etc. So all the steps are here, so need not to worry. And for the AWS point of view, there is a separate GitHub page is available by the AWS secret store CSI driver. Means this particular driver is provided by the AWS. So if I say the AWS, right, so secret store CSI driver, so this is the what the driver I am going to use, right? This driver is provided as a ephemeral, but ephemeral as a container storage interface driver for mounting secrets, keys and certificates. Secrets from where? AWS. So let's go there right now. So first of all, this is what the my Kubernetes cluster, right, and I'm going to use the AWS, and the steps are like a first step, AWS. First I need a Kubernetes cluster. So what I will do is I'm using my Kubernetes cluster, which is as a EKS, right, and go to the clusters, and EKS cluster, it's not created yet, and just quickly create it, right, my EKS 1, and it's the latest is 1.23, even though it's a 1.25 feature, but 1.23 also it's available, right? So need not to worry about that. And then next VPC, and rest everything will remain same, and VPC NI. So I can create my EKS cluster in a many different ways, but this is the easiest way, right? You just go click and create, right, and it will take a time to create, and meanwhile I will wait, right? So this is a cluster is getting created, right, and cluster is created, so it will take a time. Then the second step is create a secret in AWS secret manager, right? So this is a AWS secret manager, and I am in a Singapore region, and I have already created a secret called a simple my secret, right? And if you look at the secret value, it's a very simple password, admin@321, just a very simple password, right? This is the one. Then this secret is has to be created in AWS. I created cluster, I created secret, I created. Then second is create a IAM policy role for EKS OIDC. Means secret I created. This secret, who is going to access? This secret is going to be accessed by the Kubernetes cluster. In order to access the Kubernetes, first of all I need to define a policy where we will define in IAM. So go to the policies. I already created a my secret policy, which is a very simple policy, right? Right, and it's loading. So secret manager, get secret value, secret manager, describe secret. So just to take the secret and secret ARN, right, and here this is the what the ARN, and just edit the JSON, right, and what secret you are going to use here, right? So and I think it's already there, right? So need not to worry, right? It's a simple. This is just a policy I defined. Then go to the slide and role. Before creating the role, I have to complete my Kubernetes cluster creation. So my cluster is created, but worker nodes are not yet created. So I will just quickly add a worker nodes. My group one, just simply I will give a simple name, and IAM role is already created, and I'll just quickly finish off this, right? And T3 medium, right, and I will quickly delete this. I will choose only the private subnet, not a public, right? And then next, then my worker nodes will be created shortly. My worker nodes are created now in a ready state, right? So now the next step, so create a role for EKS OIDC. So here the Kubernetes cluster I am using, which is in the EKS provided, right? But you can use a Minikube cluster, or you can use on-prem Google Cloud, any other Kubernetes cluster which is hosted, right? But the another one major important requirement for this particular use case is it is available in this particular GitHub is as a prerequisite, which is also available in the GitHub basically AWS blog, right? As a prerequisite, the first step we need to associate an OIDC provider. So here the my EKS cluster is already given a ready-made OIDC provided URL, but whereas if you create your own Kubernetes cluster like a Minikube or any other, you have to do the setup of this OIDC, right? So that's what you have to do. Then by using this OpenID connected URL, you have to create an identity provider and role. So before that, I need to enable by using this particular command. The first step, I will connect to my Kubernetes cluster. So AWS EKS, the region basically where is my Kubernetes cluster is hosted, which is AP Southeast 1, and update kubeconfig and name is my EKS1. This is my cluster. So when I hit enter, it's, by the way, AWS is already configured in my machine, right? So now kubectl get nodes, right? So it will connect to my Kubernetes cluster and it will show me, right? That's a good sign that I am able to connect, right? That's perfect. Now as per the documentation, right, I need to associate the OIDC provider first, right? Even though it's there. So this is a command which I need to associate, right? Which is, I have already prepared that command, right? So this is the what the associate OIDC provider, and my cluster name is EKS1 and AP Southeast 1. So and which will associate the, right? So this is associated. The next step is we have not created a role, so go to the Kubernetes cluster and which is EKS OpenID connected provided URL, copy here and go to IAM and identity provider, add identity provider OpenID connect, paste the URL, whatever your cluster you are set up, right? Not only EKS, this OIDC setup URL and thumbprint. So since it's a AWS, so we need to use the audience as sts.amazonaws.com, right? So here let's close this, right, and add a provider, right? It's a provider has been created. Now go to the role and create a role which is role for who is going to use this particular role. So here this cluster may be anywhere. It's connecting AWS by using a OIDC, which is OpenID Connect. So OpenID Connect comes under the web identity of who is the provider. Just now we created, right? There is a provider to the AWS and audience is this guy, and next this provider, right, this particular federated authentication, what it's going to read, it's going to read the secret which is created, right? And then next, and the and we have to give a some name. So my secret role, I will give the name. And yeah, the one thing is here, this is the policy we have to modify, right? Instead of AUD we have to give a sub, that we will see further. And now let's create the role, right? And its role is going to create. Now the role part is completed. Now next, install AWS CSI driver. Yeah. So before going to install, right, so it's here in the, you can install by using a Helm chart, right? So and Helm repo add, so which is I will going to add Helm repo add is already added, right? Before this particular demo I tried. And Helm install. So here Helm install you can customize. What I did is here, right? So what I am doing is here I am installing in the kube system namespace this driver and enable rotation equal to true. Means if somebody goes to the secret and change this value, automatically it will rotate in my cluster. And pole interval, how frequently this particular my CSI driver and provider is going to synchronize. So those are the parameters I set, because I wanted to, my objective is to set this particular as a volume mount. That's what the my objective, right? So this is the what the configuration. So I'm just wanted to install that, right? Now it's getting installed. Since it's Helm based, it will take a time. So it's created and installed in the kubesystem namespace, and they given a command as well just to check whether it's correctly installed or not. So just when I press enter, right, it's created CSI driver. So let's try to analyze that. See what is CSI driver, right? So a kubesystem kubectl API hyphen resources. If I do that, right, so here under the storage.kubernetes, right, if you observe here, CSI driver, CSI node, CSI storage capability, storage class, volume attachment, these are created. But today's is CSI driver, right? So and kubectl get CSI drivers. See what it's created. There is a secret store CSI driver is created just now for 53 seconds ago, and 45 minutes ago, means which when I created a cluster which is EFS was there by default, right? And also there is a CSI nodes. Let's see what, try to understand. kubectl get CSI nodes, right? So CSI specific nodes, since it's my 2 node Kubernetes cluster, right, 2 worker nodes, so it's showing me that, right? And another one is kubectl get daemon set in set -a. So this CSI driver, when I installed, it's created the secret store CSI driver daemon set as well, right? And kubectl get pod -a, if I do that, right, it's created the secret store CSI driver pods which has 3 containers internally, and rest of the pods are specific to the AWS, right? So now this is done. Then another step is CSI driver we installed successfully. Now install AWS CSI provider, so and which is there in the documentation as well, right? Here step 2 is done, right? And install the secrets and provider. So here provider we will install. For a provider point of view, go to the GitHub also, it's there here. Installing the provider, you need to install the simply provider, right? And then go here, right, and then right, so it's going to install. So what it is, AWS provider, what it does is it's created one CSI driver, one service account, cluster role binding, and another daemon set which is created, right? Service account and graph for CSI, right? Yeah, so this is the what the, so one is 36 seconds ago, one is CSI driver specific, right? And here we notice that cluster role binding, right? So let's try to see. So this is a cluster role, right? So and kubectl describe cluster role, and right, cluster role is a global. So if you do that, one service account, it has all the access to create the service account, and nodes pods get access, right? And also kubectl describe cluster role binding, right? This is the what the cluster role binding, which is whatever the service account which is created, right, that service account which is mapped with the cluster role, right? Now all good. Now go to the slide, create a Nginx service account and deployment. So before creating a Nginx service account and deployment, so there are a CRDs are created by the driver. kubectl get CRDs, right? See, these are the CRDs are created. But if I deploy, so I have a Nginx deployment which is also available in the GitHub as well, right? This one. So Nginx deployment point of view, this is my Nginx deployment, right? So Nginx deployment is this, and Nginx deployment specific, first I need to create a secret provider. So this secret provider class is already created, this CRD. If you look at here, kubectl get secret provider class, right? This is the one, nothing is available. So you have to create a first secret provider class targeting what is your provider going to do. My provider is going to do Nginx deployment AWS secret, and object name is a secret. So here my secret is this my secret and password is this, right? So what my object name is a secret name and provider is a AWS. This is the what I have to install. So in order to install that, just copy this path and go here, right? kubectl apply -f, and then my secret provider is installed. So kubectl describe, right? Secret provider class, right? And what is the secret provider name? Nginx, right? So Nginx, and it will give you the what this particular secret provider is going to do, right? Now the next step is Nginx service account and deployment. So before going to do that, Nginx deployment is using a separate service account called Nginx deployment service account, right? And that service account specific YAML is here. This service account is tagged with the role of my secret role. So in the previous step I have created a role, right? In my secret role, copy this particular role ARN, right? And go here, right? And just paste it here. Now apply this particular service account. So I will go here, kubectl apply -f, and then my service account, right? It's my service account is created, right? So and if I wanted to see kubectl describe service account, and what is the service account name? Nginx deployment SA, which is assuming the my role, which is this role, right? So right, so now describe this particular service account, right? This is the what my service account. But one thing here we have to modify here is this particular my role is giving an access to my secret whom this is the what the OIDC, right? This OIDC, the cluster which is connecting by using an OpenID framework, right? This is the one. And but here instead of sts.amazon.com, so we have to give this to a specific to the my service account, so which I have already prepared here, right? Why we are doing, I will tell you that. So this is the what the, so here go there and right, so and by the way this is correct, right? And go to the cluster here, this is the what the correct, right? Now so the what it means is my service account is exist Nginx deployment service account, which is in the Kubernetes cluster, which is exist in the default namespace, is going to use this particular role. That's what the this condition means. I can put the star as well, but I am just giving the specific access only, means this pod only is going to access the Kubernetes cluster by using an OpenID connect way, right? I hope this is helpful, right? And now I will save this, right? Now the last step is have to do the Nginx deployment. So Nginx deployment, this is a service, and this deployment point of view as this Nginx deployment, and the container is just a simple Nginx, and volume point of view secret store online, this is a driver, and volume attribute secret provider class is this is the provider class, right? As I have shown, right? kubectl describe secret provider, right? Sorry, not kubectl describe. So if I do kubectl get, so it's in the CRDs, right? So secret provider class, yes, this is the what the secret provider. So kubectl get secret provider class, right? This is the what the my secret provider class, which is mapped to the my deployment. So when I try to deploy, automatically it will pull the this particular secret provider class is telling about the actual secret, which has to be pulled, right? And then mounts into this particular deployment. So I will just copy this, and now kubectl apply -f, right? now Nginx deployment is created. So now the it's created, right? So now the next step, verify the pod has a secret. So I will go here, right, and just clear kubectl get pod. I have created in the default namespace this Nginx deployment, by the way. And the most important thing is your Nginx deployment is in the default namespace and service account is also in the default namespace, right? And the secret provider also has to be in the default namespace. If your deployment in different namespace and then secret provider class in different namespace, it's not going to work. In order to test, kubectl execute in, I will go inside this pod and --sh. I'm inside this particular pod, right? And if you look at my deployment definition, right, Nginx deployment, secret store provider class is bringing the calling this CRD. The CRD will bring the secret and mount it in this particular directory. So I will go pod here and just do the cd, right? And here ls is my secret is available, the cat, right? So say my secret, right? Now password admin at 321. So now if you go here, the secret, right, my secret value, whatever is available in the cloud, this secret has been synchronized into the my pod. So what I will do is admin at 321 instead of that admin at 456 789 something I wanted to change. So I change this and interval is a 30 seconds. So I will just wait 30 seconds and then requery, right? I will pause the video. Now my 30 seconds are over. I will now what I will do is I will try to execute the same command, cat my secret, right? The password has been synchronized. So that's what its overall demo. So the thing is, here I have mounted the secret as a volume here, whereas you can mount this particular secret as an environment variable by making a changes into the driver. If you look at this provider, right, so this is what the AWS provider is installing a service account, cluster role binding and daemon set, etc. So in this particular cluster role, so you need to add on what namespace you want to access what, and also provider classes, this one we have seen, right? Yeah, that's it for this particular session point of view. I hope this particular session is helpful. Sorry for the long video, and let me know what you guys think about this particular feature. I know it's a bit complicated, yeah, but yeah, I hope this is helpful. Thank you, bye bye.